In this problem, we have an open top cylindrical container. It's going to have a volume of 216 cubic centimeters. We want to know what dimensions, meaning the radius and the height, that will minimize the surface area. So let's draw a little diagram here. So there's the base, here's my height, cylinder, and it's an open top. Okay, so there is my radius R and the height H. Okay, we want to minimize surface area. So that's going to be our objective function. You could call it S or A, whichever. And the volume has to be 216, so that's going to be my constraint. Volume of a cylinder is area of its base times the height. That's any prism. So area of the base is a circle, so pi r squared times the height h. Okay, that's the constraint, but let's go back to the objective function, and that is surface area. I'll call A. Now it's open top, so we don't include that. So it's the area of the base times the area of the sides. The base, the area of the base is pi r squared, area of a circle. Okay, the area of the sides, this is where you have to imagine unrolling the cylinder, right? So if we were to unroll the sides, we would have a big rectangle. I'm drawing it kind of smaller here. The height of the rectangle is still h, and the width or length of the rectangle corresponds to the distance around the base, which is the circumference of a circle, or 2 pi r. Okay, so the total surface area then is the area of the base plus the area of the sides, which is the area of this rectangle, which is 2 pi r h. Okay, so this is good. This is our objective function, but it has both r's and h's. So let's use the constraint and solve for h. That looks easier. So h is 216 over pi r squared. I'm going to plug that in right there for that h. To get the area is pi r squared plus 2 pi r times 216 over pi r squared. So the pi's cancel, one of the r's cancels, and just cleaning up this area function, we get pi r squared. We're left with 216 times 2, so that's what, 432 over r, or r to the minus 1. Okay, so there's a good objective function to differentiate. So we take the derivative of that. Pi is just a coefficient, it's just a number. So the derivative of pi, or the pi hangs out front, and the derivative of r squared is 2r. So we get 2 pi r. Bringing the minus 1 down gives minus 432 r to the minus 2. We want to find critical values of that. So where does that equal 0? So we have 2 pi r equals, I'm going to move this term to the other side and write it as 432 over r squared, and then multiply both sides by r squared. Okay, so we'll have 2 pi r cubed is 432. Divide both sides by 2 pi. So r cubed is, 432 divided by 2 is 216. So 216 divided by pi. So the exact value of the radius is the cubed root of 216 over pi, which is going to be a messy decimal. So let's see here. We want, round to 2 decimal places, don't round till the end. Okay, so that's our exact value of r. And we want, let's see, the radius and the height. So we need to go find h. Okay, h is, put them both on the screen. Here we go. There's h in terms of r. So probably what I would do is actually approximate r first and then use that value to get h on the calculator. So let's go ahead and approximate r. So r is the cubed root of 216 over pi. I'm going to do 216 divided by pi. Where's pi? There we go. All to the power of a third for my cubed root. Okay, so there's r. R is 4.0967 7. We're in centimeters. Okay, so then h is right here, 2/16 over pi times r squared. So let's square r and multiply it times pi. So I'm doing the denominator right here. And then I'm going to do, oops, what did I do? I don't know. So let's I think now I have to retype it. 4.09670438. I want to square that and then multiply it times pi. Okay, there we go. I'm going to do 2/16 divided by that number. So second answer is right there. So interesting, it's the same thing, 4.0967. 4.0967. Okay, here we are rounding to 2 decimals, so let's check that again. Oops. 0967, rounding to 2 decimals. This is 6 is going to round this up, so 4.10 actually on both of those.